Math 83, Unit 2, Lesson 5. We're going to decide whether a point is on a line given its equation, and then we're going to find the slope using 2 points on a line, write an equation in slope-intercept form, and find the slope and y-intercept from that equation in intercept form. So, given the equation 18x plus 3y equals 15, we want to find 2 points that are on the line. And that means which 2 points are solutions. So we have 4 points that are given, and we're just going to find which ones are on the line. And we do that by substituting in our values for x and y. So each one of these points is in x, comma, y format. And so we're going to plug in 6 for x and then 41 for y and see if this is a true statement. Well, when we simplify this, 18 times 6 is 108. 3 times 41 is 123. Well, I can tell together there's no way that that equals 15. So this one is not a solution. Let's check 5, negative 25. We do that by plugging in 5 in place of x, and then negative 25 in place of y in the equation. 18 times 5 is 90, and then 3 times negative 25 is negative 75, and 90 minus 75 is 15, so this one works. This point is on the line. Now we're going to check 2, negative 17, and we're going to do 18 times 2 plus 3 times negative 17 and see if that equals 15. 18 times 2 is 36, and then 3 times negative 17 is negative 51, and 36 minus 51 is a negative 15, and that does not equal positive 15, so it is not this one. We're going to check 2, negative 7. We do 18 times 2 plus 3 times negative 7 and see if that equals 15. 18 times 2 is 36. 3 times negative 7 is negative 21. And 36 minus 21 is 15. So this one checks out. So the 2 points that are on the line are 5, negative 25, and 2, negative 7. Those are solutions. Now we want to find the slope using these 2 points, and our formula to find the slope is y2 minus y1 over x2 minus x1. And if we want to do our y2 minus y1, that means the y from the second point minus the y from the first point. So I'm going to subtract these two and do negative 7 minus a negative 25. And then x2 minus x1 means I'm subtracting the x value from the second point minus the x value from the first point. So that's 2 minus a 5. When I simplify this, minus a negative is a plus positive. Negative 7 plus 25 is 18. And then 2 minus 5 is a negative 3. And if I continue to simplify, an 18 divided by a negative 3 is going to be a negative 6. So our slope is negative 6. Now we want to take the equation and we want to solve for y. Now in part C we want to solve the equation for y, so I'm going to rewrite the equation here of 18x plus 3y is equal to 15, and we want to solve for y. So we need to move over this 18x. We do that by subtracting 18x from both sides. 18x minus 18x goes away, and I get a 3y equal to, and I always put this x term in front, so negative 18x plus 15. I can't combine those are not like terms. And then I want to divide everything by 3. So I get y all alone. These 3's divide out, and I get y equal to, And negative 18 divided by 3 is negative 6. And then 15 divided by 3 is 5. So right here I have the equation y equals negative 6x plus 5. I've solved it for y, and it's now also in slope-intercept form. In part D, we want to use the equation we found in C that's in slope-intercept form to determine the slope and y-intercept. Well, slope-intercept form looks like y equals mx plus b, where m is our slope and b is our y-intercept. So we can pull our slope out from this equation. The slope is the number in front of x, so right here the number in front of x is negative 6, and the y-intercept always has x equal to 0. We're going to look for b, the constant, which is right here, and that's 5. So our slope is negative 6 and our y-intercept is 0, 5. If I look back to part B, we found the slope to be negative 6 as well when we use the 2 points that were solutions. In part 2, we want to decide whether an ordered pair is a solution of a system of equations. And we want to know, is negative 2, negative 1 a solution to the system? And to be a solution, it needs to work in both equations. When we plug in x and y, we need to have a true statement. So we're going to let negative 2 be our x, and we're going to let negative 1 be our y, and we're going to substitute those values in and see if we get a true statement. So we have y equals, well, instead of y, we're going to put a negative 1, 3 times, and instead of x, we're going to plug in negative 2 plus 5. And we want to know, is this a true statement? Well, negative 1 equals, we can simplify 3 times negative 2, that's negative 6. And negative 6 plus 5 is equal to negative 1. So yes, this is a true statement. So negative 2, negative 1 is on the first line. But it has to be on both to solve the system. So now we're going to plug it into the second equation. Negative 1 equal to a negative x. So we want to plug in for x a negative 2 minus 3. A negative 1 equal to, and then a negative times a negative is a positive. That's going to be a positive 2 minus 3. And then 2 minus 3 is negative 1. So negative 1 does equal negative 1. That's a true statement. Therefore, negative 2, negative 1 is a solution to the system because it worked in both equations. So we say yes. Now go ahead and do numbers 3 and 4 on your own. Pause the video and then come back and check your answer. In number 3, when we plug in negative 4, 6 in place of x and y in the first equation, we do 2 times negative 4, that's negative 8, and then plus 3 times 6, that's 18. And negative 8 plus 18 is positive 10, and that does not equal negative 10. Therefore, negative 4, 6 is not a solution. If it doesn't work in the first equation, we can just stop right there because we know it's not going to work for the system. In number 4, we check 7, 4 to see if it's a solution to the system. When I plug in 7 for x and 4 for y in the first equation, we get a true statement. And then when we plug it into x and y in the second equation, we also get a true statement. Therefore, 7, 4 is a solution to the system, and we can say yes. Part 3. Solve the following system of equations by graphing. Before we actually graph them ourselves, we're going to determine the solution of each system of linear equations if we're given the graph. And then later on, we're going to go ahead and graph the equations ourselves. So in part A, we're given y equals 2x plus 3 and y equals negative x minus 3, and both are already graphed for us on the same coordinate graph. To find the solution, we want to find the point where the two lines cross. And we can see right here in the graph that they cross at the point negative 2 negative 1. Therefore, negative 2, negative 1 is the solution to the system. Not only is it the point where they cross, but if you were to substitute in negative 2 for x and negative 1 for y in both equations, you would have true statements. In part B, we have the equations y equals 2x plus 3 and y equals 2x minus 3 graphed on the same coordinate plane. You can see when they're graphed, those lines are parallel and that they're never going to cross because parallel lines never cross. Therefore, this system has no solution. In part C, we're given the equations x plus y equals 4 and 2x plus 2y equals 8, and both of those lines are graphed. And you can see on the graph that both of them are lying right on top of each other. That means the lines coincide with one another. Then we have an infinite number of solutions because every single point on the line is a solution. Both equations share all the exact same points. So there are three different types of answers we could get when we're trying to solve a system. We could either get a point where the two lines cross and we give the ordered pair of the point, and this is true when we graph the lines. Those two lines intersect at a point, and the point where they intersect is going to be the solution. So we're going to get a point when the lines intersect. We are going to get no solution if on our graph we get parallel lines. Those lines will never cross, therefore there's no point that they share. And we're going to get infinite number of solutions when we graph a line and it's the exact same line lying right on top of each other. So the lines are going to coincide. That means that every single point on the line is a solution. Sometimes we call this the same line. Now in number 6, we want to go ahead and graph each of these equations on the same coordinate graph and determine the solution. First, we'll start with y equals 2x minus 3. Now we have graphed this several different ways. One way was to make a t-chart, pick values for x, plug them in, find values for y, and then go ahead and plot those points. A second way we learned to graph is by pulling out the slope and the y-intercept and using those. I'm going to go ahead and do this one with a t-chart, which means I can just pick whatever values I want for x and then substitute them in. If I plug in 0, 1, and 2, I can put 0 in place of x, and I'm going to get 2 times 0 minus 3, and 2 times 0 is 0, minus 3 is negative 3, so we have our first point here of 0, negative 3. Plug in a 1, that's 2 times 1 minus 3, and then that's a 2 minus 3 is a negative 1, so the next point is 1, negative 1. And then we can plug in a 2. 2 times 2 is 4, and 4 minus 3 is 1, so we have the point 2, 1. Go ahead and connect those points with your straight edge. Now we need to graph the line y equals 1/2 x plus 3. Well, for this one, we'll go ahead and use a different technique. We'll first find the slope and the y-intercept from the equation. So the slope is the number that's right in front of x, so that's 1/2. And the y-intercept is always 0, comma, and whatever b is, that's this constant here, so that's 3. And we can start by plotting the point 0, 3 on our line. Then we can find a second point by moving along on our graph a rise of 1 and a run of 2. So we're going to go up 1 over 2 and find a point. Then we're going to go up 1 over 2 and find the next point. We can see that these two lines are going to cross at the point 4, 5. Therefore, 4, 5 is the solution to our system. We can double check by substituting in 4 and 5 into our equations to make sure we get true statements. So to find out, let's go ahead and put that into the first equation. So if I put in 4, we get 2 times 4 minus 3, and 2 times 4 is 8, minus 3 is 5, so yes, this point is on the line. And when I double check over here on the second equation, I get y equals 1/2 times 4 plus 3, and we want to see if that equals 5. Half of 4 is 2, plus 3 is equal to 5, so it works in that equation as well. So our solution is 4, 5. For number 7, I want you to go ahead and graph y equals x plus 1, either using a t-chart or using the slope and y-intercept, and then graph y equals negative x minus 3, and find the point where they cross. Pause the video now, and then come back and check your answer. Let's take a look at the answer for number 7. The solution is -2, -1. We found that by first graphing y equals x plus 1. I did that by pulling out the slope of 1 and the y-intercept of 0, 1. I plotted the point 0, 1 and found more points by going up 1 over 1, up 1 to the right 1, up 1 to the right 1, and connecting those points. Then we looked at the second equation, y equals negative x minus 3. This time I decided to use a t-chart and pick values for x. I picked 0 and I got a -3, and then I picked a 1, plugged it in and got -4, and so forth. And once I connected those points, I saw the two lines crossed at the point -2, -1, and I double checked that xy of -2, -1 worked in both equations. It worked in the second equation, I knew, because it was in my chart, and then when I plugged it here back in the first equation, it also was a true statement. Now go ahead and try number 8 on your own as well. You can graph it with using any method you'd like. Pause the video and then come back and check your answer. Now when we take a look at number 8, I chose to graph both of these lines using the slope and y-intercept from the equation. In y equals 2x plus 1, the slope was 2, the number in front of x, and the y-intercept was b of 0, 1. So I plotted the point 0, 1, and I found the second point by going up 2 to the right 1, and the third point up 2 to the right 1, connected those points. And then in the second equation of y equals 2x minus 4, the slope was 2 and the y-intercept was 0, -4. I started by plotting the point 0, -4, and then using the slope of 2 to go up 2 to the right 1, up 2 to the right 1 to get the next points. You can see these two lines are parallel, and because they're parallel, they're never going to cross, therefore there's no point that they're going to share. Therefore, this system has no solution. You can tell because the lines are parallel. Another way you can tell the lines are going to be parallel is by looking at their slopes. Both of these have a slope of 2. If the slopes are equal to one another and their y-intercepts are different from one another, you're always going to have parallel lines, which will give you no solution. Go ahead in number 9, graph these two equations on the same coordinate plane, and then come back and check your answer. If we take a look at number 9, we take the equation y equals 3x plus 1, and we pull out the slope, which is 3, and the y-intercept, which is 0, 1. We plot the point 0, 1 on the graph, and we use the slope of 3 to find another point by going up 3 and to the right 1 on the graph. We also can come down 3 and then go to the left 1 if we'd like to find other points towards the left of the graph. Then, when we take 2y equals 6x plus 2, before we can pull out the slope and y-intercept, we need to get y by itself. So we have to divide everything by 2 to do that. And that gives us y equals 3x plus 1, which also has a slope of 3 and a y-intercept of 0, 1. And we can tell right here when we get y all by itself that these are the exact same equation. So when we graph it, they're going to be two lines that are lying right on top of each other. So those lines are going to coincide. Therefore, every single point on that line is a solution, and we say that this has an infinite number of solutions. Now in number 10, we first have to solve for y to get it in slope-intercept form in order to graph each of the equations. So I'll start with the first one. We have negative 2x plus y is equal to 4. To get y by itself, I'm going to add 2x to both sides, and I'm going to get y is equal to 2x plus 4. Now that I have y by itself, I can pull out the slope and y-intercept. We have a slope of 2, the number in front of x, and then we have a y-intercept of 0, 4. It's 0 and our b value here, 4. So I'm going to go ahead and plot the point 0, 4 on my graph, and I'm going to use the slope to find more points. If the slope is 2, that's the same as 2 over 1, so that means I'm going to go up 2 to the right 1 to find another point. Now that I've plotted my first point, I can see that if I continue going up 2 over 1, I'm going to be off the coordinate graph. So I can also take this slope and do negative 2 over negative 1, because I know a negative divided by a negative is a positive, and I can come down 2 to the left 1, down 2 to the left 1, down 2 to the left 1 to find more points. And then I'm going to go ahead and connect those points to graph the line. Now I'm going to take the second equation of negative x plus 2y equal to negative 4, and I'm going to solve for y. I do that first by moving this minus x over to the other side. I add x to both sides, and I get 2y is equal to x minus 4. And then I have to divide everything by 2 to get y by itself. And I get y equal to, and the number in front of x is 1, and then I have a 2 in the denominator, so that's 1/2 x minus, and then 4 divided by 2 is 2. Therefore, if I pull out the slope, that's 1/2, and the y-intercept here is going to be 0, negative 2. So first I'll start by plotting 0, negative 2, our y-intercept, and then I'm going to use the slope to find more points. I'm going to go up 1 to the right 2, up 1 to the right 2, so that I can see where it's going to cross down here. I can also come down 1 and to the left 2, down 1 and to the left 2 to help me. Go ahead and connect those points now. Now, when I connect the points, I can see that these two lines are going to cross each other, and they're going to cross at the point negative 4, negative 4. Therefore, negative 4 is the solution to this system, and we've solved it by graphing the two lines.